Good morning, everyone. My name is Vaibhavi Dattatreya Godade, and today I am going to present my embedded system internship project on advanced driver assistance system. The project was developed using STM32 Cube IDE, PiximLab, Teraterm, VSP, and a Python dashboard. Through this project, I learned how embedded systems are used to improve vehicle safety and monitoring. So, this slide contains which topics I had learned in internships. So, I have learned the topics like introduction and project overview, STM32 environment, and also I learned about ADC and analog sensor inputs, ultrasonic sensor, timers, interrupts, EV control module. Also, I learned UART communication protocol and Python dashboard. Then next is what is mean by embedded system. Before discussing the project, let us understand what an embedded system is. An embedded system is a computer system designed to perform a specific tasks inside a larger devices. It consists of both hardware and software working together. For examples, washing machines, microwave ovens, smart TVs. All these are the examples of embedded systems. Next is project requirements. ADAS project requires or includes STM32 Cube IDE, PiximLab, Teraterm, VSP tool, Python dashboard. So mainly STM32 Cube IDE is used for writing and debugging the embedded C codes. Then PiximLab is used to simulate the STM32 hardware. Then Teraterm is used for serial communication and UART communication. Then VSP is mainly create a virtual COM ports for communication. Then Python, PySerial and Matplotlib is used to build a real-time dashboard showing vehicle parameters. Then next slide is project workflow. So this flowchart will show the project, how project will flow in stepwise. So first is the PiximLab simulation, which simulates the STM32 hardware. The firmware written in STM32 Cube IDE runs on the simulated controller. Then STM32 sends vehicle data through the UART communication. Then vehicles data sent through UART communication. Then this data is displayed on Teraterm. Then using VSP, the serial data is shared with the Python application. Then finally, the Python dashboard displays real-time information such as vehicle speed, torque, acceleration, faults, then battery percentages, motor temperature, then obstacle distance. So likewise, the project will flow. First PiximLab will in picture, then next STM32 firmware, where I wrote the code of overall project, which includes EV controller, UART, ADAS, then fault manager. All these codes are I wrote in STM32. Then these all codes are connected through UART communication protocol to the Teraterm, and on Teraterm this all data will show. And then VSP, which contains dashboard will show the actual things how work. Then next is PiximLab simulation. This slide shows the PiximLab simulation. PiximLab provides a virtual STM32 development board where we can test our firmware without using physical hardware. It allows us to simulate switches, LEDs, sensors, and serial communication. This makes debugging easier and reduces hardware dependency during development. So for ADAS project, I use Pixim Lab to build a hardware to build a s- ha- to build a connection without using the physical hardware. So here I use the potentiometers for acceleration pedal, brake pedal, SOC, and motor temperature. Also I use the ultrasonic sensor for the distance, left side distance, front side distance, and right side distance. Then here is the virtual terminal, will show the output of all these things. That's why for without using hardware, I use the PiximLab simulation. Then next is STM32 Cube IDE. STM32 Cube IDE is the main development environment used in this project. Here I wrote the embedded C program, configure peripherals, compile the projects, and debug the firmware. STM32 microcontroller controls all the project operates such as a sensor reading, UART communication, timers, ADC, all that things are controlled by the STM32 Cube IDE. Then features. Here are the features which all are implemented in the ADAS project. GPIO is implement for controlling LEDs and digital inputs. Then ADC, analog to digital converter, is for reading analog server values. Then UART, universal asynchronous receiver transmitter protocol, is used for communication with the devices. Timers is used to generate the periodic events. Then also state machines are managed different vehicle operating modes. Fault manager is used to detect abnormal conditions. Then ADAS engine is implemented to monitor obstacle distance and generate safety warnings. So these all are the features which are implemented in ADAS project. Next is a dashboard. Here dashboard Here this dashboard is shown in the VSP tool, which contains the vehicle speed, then alarm, then all EV metrics also shown in this dashboard, like a torque, acceleration, brake, motor temperature, alarm, fault manager, signals. All these things are shown in this dashboard. Also bird's eye obstacle view is also shown here, like in this way. So all these things which are I implemented in Pixim Lab, and in that Pixim Lab on virtual terminals, which all whatever the things are shown of vehicle parameters, which all these are things are also shown in the dashboard. Then last is a conclusion slide. Uh, in this project successfully completed EV ADAS embedded system project. This project helped me to understand the practical implementation of embedded system in actual automotive applications. In this project I learned embedded C programming, how debugging is actually done, serial communication I also learned, and firmware development. This project improved both my technical knowledge and problem solving skill. So in this overall project, I learned what is actual embedded systems are used in the industry automotive applications. So this project will help me to improve my technical skills in embedded system. Thank you.